Here's a real world problem for you. Okay, you find yourself at the edge of a cliff, and in a spasm of irrationality and insanity, you throw your keys horizontally at 8 meters per second from a cliff that's 64 meters high. Now you have to go down and find your keys now. Maybe your significant other was irritating you, so I'm sure there's an awesome backstory to this that you can put together for your English class. But so we want to know how far from the base of the cliff should you look for your keys. Okay, so let's use good problem-solving technique here. We're going to use given, find, and solve with a picture. Given. Okay, your keys 8 meters per second from a cliff, 64 meters. Let's draw the cliff. And this is one of the types of problems that you're going to have to solve for projectile motion problems. And here's your, here are you standing on here, and you throw the keys like this, horizontally. Whoops, let me zoom out a little bit. And you throw your keys horizontally. And the initial velocity is 8.0 meters per second. Now, think about this though. If you throw it horizontally, this is the initial velocity, but it's the initial velocity in what direction? That's the horizontal, the x direction. Let's make this the x direction and this the y direction. That's our coordinate system. So this is really the initial velocity in the x direction. If you throw the keys horizontally, what's our initial velocity in the y direction? Zero. So one of the first things you should do when you're given a projectile motion problem is ask yourself, what are the components of the initial velocity? In this kind of a problem, the initial velocity is all in the x, the initial velocity in the y direction is 0. Now the keys are going to fall down how far? Delta y equals 64 meters. Okay, down. But it's down, right? The keys start way up here and they fall down. So delta y is really negative 64 meters. And of course we know that this is on Earth, right? So we know gravity is negative 9.8 meters per second squared. So let's draw the trajectory. It's a nice little parabola, kind of a shape like that. So here's the ground down here. And what are we trying to find? We want to know how far from the base of the cliff. So here's the base of the cliff, and this is really delta x, isn't it? How far from the base of the cliff did the keys land? And so now you can know where to look. Well, since we're, find delta x. So let's solve it. Well, there's only one equation that has delta x in it for projectile motion. That is delta x equals the initial velocity in the x direction times time. So this is what we're trying to find. Yay, it's already solved for. But what's true about v naught x? Do we know that? Yeah, it's given. What do we not know? We don't know time. So where do we have to go to be able to solve for time? We have to look at the motion of the object now in the y direction. Okay, so what do we know in the y direction? We know the initial velocity is 0. We know what the acceleration is, and we know how far down it's going to fall. So we know delta y, initial velocity. We're trying to solve for time. What do we not know and not need in the y direction here? We don't know the final velocity in the y direction. So and that means that, what equation doesn't have the final velocity in it on our kinematic equation list? It would be the third one, and this is the one we usually use on projectile motion problems. Not always. Delta y equals v naught y times t plus 1/2 a t squared. So when you look in the y direction, you really have to figure out, okay, which equation am I going to use? Well, nicely, this is 0, and we know what delta y is, and we know what a is, so solve for t. So t is equal to, multiply both sides by 2, so that's 2 times delta y, divide by a, and take the square root. Now we're ready to plug in numbers. 2 times negative 64 meters divided by the acceleration, and that is what? Negative 9.8 meters per second squared. And this gives me a value for time. And what do we get? So go ahead and work it. Well, I looked for my calculator. I don't want to use this one. So go ahead and work it yourself. I'm working it right now. What'd you get? 3.614. We could round that off, but I'm going to keep 4 significant figures for right now. Okay, so that's how long it takes for it to fall. Now we're ready to solve for delta x. We know what v naught x is. That's 8 meters per second. And now we know what the time is. And so delta x is equal to 8 times 3.614 equals, and I get 28.9. Yeah. And I mean, you can keep 2 or 3 significant figures, whatever you want. I'm going to keep 3, just 28.9 meters. So that means that your keys are going to land 28, almost 30 meters away from the base of the cliff. And now you know where to look. Isn't that special? All right. Let me zoom out and see the whole thing.